Welcome back to the channel. So today in this video we are going to understand a little bit more about sets, or you can say set theory. So here we are going to discuss some types of sets. The first type is spatial sets. So what are spatial sets? So here we are going to understand standard notations used to define some sets. So we have capital letter N is used to represent set of all natural numbers. So we know natural numbers, we start from 1 and go up to infinity. Similarly, we'll use capital letter Z to represent set of all integers. So we'll be having negative numbers, positive numbers and 0 as well. Capital letter Q will be used to represent set of all rational numbers. Here we'll be having A over B, where A and B belong to integers and B is not equal to 0. So in case of rational numbers, we know that denominator can never be equal to 0. We'll be using R, capital letter R, to represent set of all real numbers. So here we'll be having the set of all x such that x corresponds to a number on the number line. We know that each and every number on a number line represents a real number. And we'll be using capital letter C to represent set of all complex numbers, where we'll be having a plus b iota such that a, b both belong to real numbers. So now here we are having examples to understand these standard notations. So here we are having set A, where x belongs to real numbers such that x is greater than or equal to -1 but less than 3. So here we are using capital letter R to represent real numbers. Similarly, we have set B where x belongs to z such that x is greater than -1 but less than 3. So here we are using capital letter Z where z represents set of all integers. And we are having set C where x belongs to z positive. So z positive represents set of all positive integers. It represents set of all positive integers. So here we are having x belongs to z positive such that x is greater than -1 but less than 3. We have a second category of sets, which is singleton set. So what is a singleton set? A singleton set is a set containing exactly one element. So if a set contains only one element, it will form a singleton set. Let B is equal to the set of all x such that x is an even prime number. So we know in this very case, if we represent set B in roster form, it will be having only one element, that's 2. So therefore we can say that this set B is a singleton set having only one member, which is 2. Similarly, we have another set A. Here we are having the set of all x such that x is neither prime nor composite. This set will again be having only one element, that is 1. So this set A is also a singleton set. Next category is empty sets. So a set which does not contain any elements is called as empty set, or it's also called null set, or you can say void set. This is denoted by phi or empty braces. So what are the examples of empty set? Here we are having the set of whole numbers less than 0. So we know that there is no whole number which is less than 0. Similarly, here we are having under set N where we have the set of all x such that x belongs to natural numbers and x is greater than 3 but less than 4. There is no natural number which is greater than 3 as well as less than 4. So this again has no element, that means it is also an empty set. Let A be another set where we are having the set of all x such that x is greater than 2 but less than 3 and x is a natural number. So here again there is no number which is greater than 2 as well as less than 3. So this again forms an empty set. Another example, here we are having the set of all xi's that x is a composite number less than 4. There is no composite number which is less than 4. So this again forms an empty set. I hope this makes sense. Do subscribe the channel and thanks for watching.